and I do performance engineering for OpenShift, OpenStack, and Gluster, and some of the container pods also. So you think that why DevOps, and why I'm talking about that? First of all, OpenShift. Other reason is for performance engineering also, we are kind of using the DevOps environment. So basically, if you want to test something or application performance wise, so we do automation through Jenkins, we deploy it on an environment, then we use Taurus and BlazeMeter and all those things to kind of do the testing there. So kind of have some of our background from performance perspective to DevOps as well. So today I will talk mostly about OpenShift and basically innovate at the speed of open source with DevOps. So we all know world is changing. How we can see that? Right? We can all see that things are changing pretty fast. And everybody wants to have an app for their software deployed on the cloud, being used from the day one. It's kind of putting more pressure to not pressure per se, but it is making your job more excited. So, and all the companies are doing analytics. You install any app on a mobile, right? Fitbit, Flipkart, Google, they're all trying to get the data from your laptop or from your mobile, put it on some environment there, do some data crunching there, and come up with more products. And that's how we are all kind of doing to the digital world. Some of those examples are Amazon, Square, Apple Pay, Netflix. So all of these, right? You use the app every day. Maybe for coming to a conference, you might have used Uber, Taxi4Sure, or anything else to come to the conference. So yeah, like so much of things are happening, right? How do you know what to do, what not to do? And eventually things would settle down and you would know that, okay, things are now good in state. So basically we have seen a lot of things over time, right? We have seen first physical machine, then we moved to virtual machines, now containers. So eventually now containers are new, but VMs are like there for like a couple of years. We all know how VM works, how we use VMs and all those things. But if we talk about containers now, they're all kind of becoming de facto standard. How many of you are agreeing on that? Yes, containers are becoming de facto standard for doing any deployment, anything, right? So eventually things will settle down and we know what to use. So there are 3 questions everybody is asking right now is how quickly I can deliver, right? Your manager would ask you how quickly you can deliver. What kind of apps and services to deliver that support? And where do you create those apps so that you can deploy them quickly, faster to make all the demands. So how? DevOps. DevOps is the thing which is going to solve how quickly and reliably you can deliver. What? You would write your apps cloud natively so that whenever you write an app, it's a cloud native app. It goes to a different environment. It goes to the cloud from your CI/CD environment and just kind of go deploy it there. Where you would deploy on a hybrid clouds, right? So that's where are we going now? So I think we all know what DevOps is. If not, I think you all know. So I don't question that. So if you're delivering any software today, what is the reality? What is the goal? So if we talk about budget, it's kind of 45% higher. Time is 77% over, and value is 56% less. That's kind of a survey. Who has done that? The survey has been done, and there's the report from there. And companies or organizations who are using DevOps, they are seeing some of these benefits. They are seeing better deployment quality, faster release, improved process visibility. Is it correct, or is it just a survey is wrong? Yes? Okay. And these are the open source tools which are kind of transforming that DevOps practices what we're doing right now. So we have Jenkins, Ceph, Git, Puppet, and there are large companies which are using DevOps regularly. Netflix, I think one of the best example what I have seen so far. There are so many projects online, open source world. Yes, Twitter, Facebook. These are all using the open source tools to deliver DevOps and apps very faster. So what would happen if we kind of combine DevOps and cloud together? We are going to basically industrialize the deployment, the cloud apps which go online very quickly. So basically if you see an example, right, we have seen this thing because of the what do you call that, workshops, or what is the correct word for that? Sorry, I'm missing that. Supply chain. It's pipeline. Sorry. Basically, if you implement a pipeline kind of things with the current industry, you can see that. I mean, you see a lot of your manufacturing goes very fast. So similarly, if you put DevOps and the cloud environment in the mix, you're going to see your apps getting deployed very faster and reliable manner. So what would you do? I mean, what would you produce if you can kind of make your cloud factory in the DevOps as a process which you can do that? So you can produce all these apps very fast. With what things you can do? You can do a complete dev test cycle. You can do a CI/CD with that. So if you can implement, if you can follow up the entire chain of the cloud and DevOps, you can do development, QE, deployment, all that thing can go in a very one cycle, in a very easy way. So that's how the complete DevOps workflow looks like. So eventually also you can go back, you can also give the feedback back to the application developer if you're kind of able to deploy your apps very fast, and you can give feedback very easily to the app developers. Okay, so currently how do you deploy your apps? Can anyone give me some examples there right now? How do you deploy your apps? Through Jenkins. Right. And where do you deploy it? Cloud. Any example of the cloud? AWS. Yeah. So that's the thing what we are seeing most of the people are doing right now. So what do you do? Basically write your app, put them in a kind of VM or a container thing, and then you deploy in your cloud platform, whatever is you're familiar with, or you have a contract or whatever this. So now let's talk about something more about containers. How many have used Docker? How many of you used? Yeah, I think most of the people have used Docker, definitely. So what does that gives you? That gives you an ability to put your app in a very jailed environment, which you can deploy it very easily wherever you want. And the other thing best with the containers is that whatever dependency you have all those dependency, put them together, and that dependency would be sitting in that app or in the container things. So basically if you say that my app needs Python, some version of MySQL and Apache, you can put them together in one bundle, and that bundle becomes a unit for you to deploy. And because you have everything in that particular bundle, that dependency hell would not come. So basically if you say that I have an app developer who is developing an app, once it comes to the QA environment or in the production, it is not working, right? So if you have that app containerized for you, and you have all the dependency put on that particular box or container, it would be run as same as it is in your dev environment, same as in QE, and same as in production. So that's what containers are doing right now. So what you do basically, you can write an app. First it can run on a RHEL environment or any of the Linux environment what do you have. Then what do you do with that? You can make that app as a cloud ready. When I say that a cloud ready apps is that it can you basically containerize that app. So now to run a very containerized app, what do you need? You need an environment on which you can run. That is RHEL, Ubuntu, whatever you use. So what people are building right now is containers host. So those hosts are very specific to run containers. Other than running an entire OS, you just run a very specific containers or very specific OS to run containers. So those are called container host. So from examples of there, Atomic from Red Hat, then you have Photon from VMware, CoreOS is one of them. So basically you make your app and then deploy your apps on top of container host. And that would, what would happen eventually when you have those container host, you can cluster them together, make them talk to each other. You can have a scale out, scale in, all those kind of features in there. So when I talk about container host, so Red Hat has Red Hat Enterprise Atomic Host that is designed specifically to run containers. So what do you see here is we have taken RHEL 7 and some packages from like Kubernetes. We kind of sort them out. Basically, we don't need the entire Red Hat Enterprise Linux there to run containers. We've just taken out the things which are required to run containers, put them in a box which is called Atomic Host, and that is specifically to just run containers. Then we have we are using Kubernetes to do the clustering and the scheduling part. So basically, we talked about this container host here. Now, if you want to cluster them together, you have to schedule your apps deployment on a given environment. What do? You can use Kubernetes to deploy those things. I'm sorry, I don't have enough time to kind of go in detail on each one of these things, so I'm kind of touching upon them and kind of giving an overview of these things. Yeah. Yeah, I'll give. Just hold on. You want to talk about multi-host microservice example. So let's say, okay, let me just fine. We can talk about it right now. So let's say this is a Kubernetes thing. If you might have seen it earlier. So what you have here is all of these yellow boxes are a physical machine. What do you have? Physical machines of VM. What do you have? All of those minions, they're called minions. Minions run Docker. Docker is an engine to run containers. So currently Kubernetes supports only Docker, but it can support others in future as well. So let's assume it's currently support Docker only, or it supports Docker only right now. And Docker runs all these pods. Pods are nothing but your group of containers that makes an app for you. So basically take an example of WordPress. WordPress would need a database and a web server, right? So what do? You put those containers for WordPress and MySQL, or the Apache and the MySQL thing in a pod. That pod would be residing in one minion if you have a replication count of 1. But if you say I want to have multi-replicated environment on that, then you can say like I want to run same replica of that pod into multiple minions. That's one example. Other thing you can think about is if you want to run your MySQL pod on one machine and Apache pod on another machine, and they want to communicate with each other, then they can communicate through the service mechanism what Kubernetes has. So basically you can access a given pod through one service API. So basically the service, not the API, a service name basically. So basically my pod might get a name like mysql.local cluster something. Similarly, if you want to access that thing from your other pod, you can say go and connect that thing. I will go and connect and do that for you.
So are you talking about high availability?
Yeah, that is one part of it. And you question about microservices, right? Yeah, so that's what I'm, so that's the thing which I was trying to answer as well. So any specific you're looking for right now?
I don't have, I'm new to this.
Okay, so I thought you have a very specific question. So microservices are, again, it's simple to think about in terms of apps, right? So whatever app you want to make, so let's say you want to run a survey, right? For a survey, you write an app. And that app, you want to deploy for, let's say, just a week, something like that. So what do? Basically, you create a pod in Kubernetes thing or on a cluster environment. Then you say, okay, go and deploy it. And depending on your environment settings, like you can see, deploy one replica in east region, one replica in west region. So you can do all those things. So you can define those kind of definition, and that will go and get deployed. So you have to kind of figure out what your application is being made of. Once you kind of decided that, and depending on that need, you can just say, okay, this is my application, go and deploy it.
But what is multi-hosted?
Okay, so these minions are multi-hosted, right? So basically, let's say your one app is running in east region, one is running in west region. If east region server goes down, it will take in west region. And so you will always go and connect to the top level guy. The top level guy would distribute your traffic. If both are up, if one is down, then it will all distribute to one machine, one of the minions. Right, and you have networking and all those things come and play here. But what happens in the Kubernetes? Well, Kubernetes doesn't understand in terms of apps. It understands in the language of pods or the containers. It doesn't understand the language of apps. So basically, if you want to talk about in terms of apps, you need to have something on top of Kubernetes, and that's what OpenShift brings in. So what OpenShift is bringing is a application definition on top of Kubernetes. So what do you have? The entire stack looks like you have first container host. It can be just RHEL or Ubuntu also, depending on your need. So if you want a very container specific OS, you choose container host. Then you have containers, definitely you have container engine Docker. Then you have Kubernetes for orchestration, basically which will kind of take multiple machines, put them together and give you a logical view. Then you have container services, or basically in the sense, if you want to take any Docker image what you have on Docker Hub, you want to run on the open or in the apps world, you can just take it and run it. So and then what do you put on top of the OpenShift? OpenShift then sits on top of all of these stacks. It gives you a logical or a very visual view of the overall environment, and you think in terms of apps. What do you think? You think I want to deploy WordPress. What do? You just go and give this guy a WordPress definition. It will do all the things in the background. It will talk to Kubernetes. It will go and do a deployment. So this is a very high level architecture of OpenShift. So what do you have is here OpenShift CLI or web GUI. What do you have? Then you have a master guy. The master guy would take all your requests. That request, like the example I say, I want 5 replicas of WordPress deployed with the same name. So basically, user would just say one name, but eventually I will go and deploy 5 of those apps. And depending on my load balancing and schedule, whatever things I choose, it will either load balance or it would do a fault tolerance, whatever things you choose there. Then you have these Kubernetes sitting at the back end of OpenShift, which would eventually go and deploy the minions, which will deploy the pods on each of those minions. So that's how the complete stack looks like. Any questions till now? Yeah.
So I just wanted to, or
into 1 million multiple pods will be coming.
Minions also, and minions would basically managed by the master server. So master server would tell you where to deploy.
No, so you said that if I want to deploy, and part is containing MySQL and another part is containing Apache and another
Right.
part is containing my app or something like that.
Right.
Okay. So if say for example I have deployed 1 million into the east region and 1 million into the west region.
Right.
My MySQL pod is crashed.
Okay.
So will that east region minion will be completely useless, or will that east region minion can?
No, so okay. So what would happen? Kubernetes says, what general thing is, whenever Kubernetes thinks something is that, it will pick another one. It will start another copy of that. So basically, it's like Kubernetes says, it will tell Kubernetes would make sure that whatever things you have said it while creating the pod. If you have said that I want to make sure that every time my one copy would run. So even if one pod dies, another pod would come up. So eventually it's like a dynamic.
In the same minion.
Wherever it is, it doesn't matter. Kubernetes doesn't worry about that part. It just worry about whatever you have said, it will bring it up. And because each pod would be identified through a service, the other guy would communicate through the same service mechanism. So for the Apache, it is just MySQL something my name, and that name would eventually get assigned to different pods if the pod dies.
And what about the data which is?
The data should not reside in the pod. Data should always be at the outside of the pod. So basically you don't want to store any data in the container. That's a best practice you have to follow.
So when we are running MySQL into that, then into pod, then we will be storing the data into the MySQL.
No. You can always add external disk inside the MySQL and put the data in that. So you are not going to store your data in the pod. Kubernetes is very yeah. So Kubernetes is not very specific to OpenShift. You can use Kubernetes without OpenShift also.
It's like clustering?
Yes, there's a clustering for containers.
Only for containers?
Yes, not for VMs. Any other question? If you install RHEL, Red Enterprise Linux, or any, let's say whatever you use, RHEL. So if you use RHEL, it would have lot of packages, right? It will have okay, I'll come to that. So first of all, if you want to run just Docker, you can do pm install Docker or apt install Docker, whatever the platform specific you have, and then you can run containers on that, right? Very simple. But now, because you just want to run containers on that machine, let's say you have a use case that you just want to run containers on that machine, nothing else. What do? You don't want to run, you don't want to have unnecessary packages sitting on that machine, which will kind of require update and all those things. So what we do is basically you take RHEL 7 and the other packages, cut them down to make sure that it is just there to run containers. That's it. So like we will remove the Genome desktop, we will remove all the other necessary things, and you cannot run yum also on that. So all those things you just remove it, and just to make sure that run containers. That is Atomic Host as a platform. Docker is just to run containers. Now, if you want to have, so Docker would anyway need a platform to run, right? It cannot just run. It doesn't have any OS per se. It has to manage the hard disk, OS, whatever. Docker doesn't do that, right, for you. And then once you have those very specific container OS, what you can do is you can cluster them together with Kubernetes. So basically what you will do eventually is you will take multiple of those container hosts, which is Red Hat Atomic Host in this environment, or if you talk about VMware Photon or CoreOS, you would put those container specific host OS and then put an app on top of that, right?
The physical machine, or will that run on a VM?
I think their primary use case is VM only, right? I'm not sure whether they can run it on the physical. So basically they will have a hypervisor, vSphere or whatever, and then you create a VM, and then that VM you would run the Photon.
So in future, do you think that people are going to replace VMs with containers?
Yes, eventually it's happening now. It's not future, it's happening now. But there's some use case where people also coming up there that say that containers are not very securities. They don't have security. So what they are doing is, or the VMware and some of the products from Intel, what they have done is they have created a very lightweight VM. Inside that they put containers. So basically for each container you start a VM also. But that's a different thinking line there.
Thanks.
Okay, so what OpenShift has? OpenShift has 3 versions or 3 variant which you can use. One is Origin, which is again so all of this is on GitHub again. So Origin is a kind of open source version which you can kind of download and use it now. OpenShift Enterprise is again kind of well QA'd work from Red Hat, and you can buy subscription for it, not the license, subscription for that. And is online is a hosted thing where you can host your application right away. So basically if you want to have an app, you want to host it, you can just go to OpenShift Online and host your app there. Just like this. So basically if you want to have a personal blog, you can just get a domain name and put your app on that for free.
2 version.
Okay.
So in the version, we not getting any support from the SMTP, because if any application, if you fails that, we will not get any mail from the SMTP. Why you people not providing the SMTP access in that 2.2 version?
I don't have any specific answer. Question I can answer you right now. It's a very general question. I mean, very specific question which you can't answer now.
Okay.
I mean, yeah. Anything else?
So is there any limitations that what we can run onto the OpenShift or not?
You can think about whatever apps you have, you can do that. So basically, if you can think about in terms of containers, you can say if you can run anything on the Docker, you can run anything on the OpenShift right now. That's a very simple thing.
When you have containers running versus when you have individual VMs running.
Okay, very simple thing.
When the virtualizer is on the top of the.
So you basically you take a hypervisor, then you partition your disk, CPU or whatnot, and install a VM on top of that, right? That's how you do it. But containers is a process. So think about running a process and a VM. What is faster?
Obviously process is faster.
Yeah.
But what I'm talking about is resource optimization. So when you're running a VM,
Right.
and say my app is very CPU intensive.
Right.
Okay, and if on a VM I have multiple containers, and one of the pods, say for example in the Minion.
No, you're talking about, the question is running containers in a VM or running containers in a, what's the question?
My question is like containers run on the top of the VM.
Not necessarily, if you want to run it.
Okay.
Not necessarily.
Okay. So I can run it independently
On the native hardware.
Okay.
Yeah, so I think that's all the slides I have. I can just take 1 or 2 more questions and that's it. There are some nitty-gritty, some points are missing now. They kind of become more secure, like user space, namespace, mechanism, SLN support is there now. So yeah, it's becoming more secure day by day. So basically, yeah, it's
So
lot of. Yeah, so first of all is you need to make sure that all of your images are very latest, or it's provided by the right guys. You cannot just take a random image and install it and say that it's being not security compliant. So you need to make sure that the images what you are getting from whichever Docker Hub, or you take Docker Hub from CoreOS or from Docker Hub directly. Whatever image you take, you need to make sure that those images are well compliant and they are updated regularly.
okay, my question is organizations can really
Okay.
utilize OpenShift.
Correct. So can I go back to the? You can use it in multiple places. First of all, if you just want to use inside your company, if you want to have like dev CI/CD cycle. So what you can do is your developer develops something. you integrate that thing with Jenkins. Whenever app puts, developer puts something, you've done QA and everything on that or whatever you want to do that. So basically that goes into kind of CI/CD environment. Then you deploy it. The deployment what you do will do in OpenShift. So basically you deploy your app on top of OpenShift. So it's a PaaS platform actually.
So is it the public cloud, or are you also offering private cloud solutions for OpenShift?
Yes, so you can, so that's what I said. So basically you have three different variants of OpenShift. One is Origin, which you can kind of just take and deploy on your environment directly. You just say, get an open source binary, currently just Go binary, deploy it on this thing, you will have OpenShift ready for you, and you can deploy your apps on that. Then you can have the enterprise version of that, the same thing, but you can have online where you can deploy it on our hosted environment. So basically you can say that, okay, go and host in this particular thing. So you can directly go and host to the environment cloud what we have.
On a public cloud?
Yeah.
Okay, and OpenShift Enterprise is for?
You can deploy, on-premise, yes, on-premise solution.
Okay, thanks.
Documentation is a little bit of documentation. Say suppose I have multiple containers, I may not be able to read it, or if someone joins a team and they may not be able to look it and know the environment faster. Say suppose we have VMs and we have physical machines. It's easy.
Sorry, come again slowly. Yeah.
Okay, so we have physical machines, VMs, and then Dockers, right? So the way we have grown up. So we had physical machines and
Okay,
VMs,
right, correct.
So if you have VMs, yes, we will be able to easily understand, and even we have consoles to manage the VMs also. So we can easily view the picturization of the architecture and how it has been put in place, and how we easily identify how many Dockers containers are there, and the representation, the documentation perspective.
That you need to kind of learn eventually. So basically think about what you can do in VMs, you can mostly do in containers. So just think about one-to-one mapping. Most of the cases you would be fine. But if not, then you need to kind of go to the much more detail and understand how it is.
Okay, so is there any utility or service that we can have so report generation, something like these many containers and these?
Yeah, so there are utilities. So basically there are some GUIs also. You can say I want one MySQL, one Apache, put them together, and then will give you a definition, and from that definition you can generate the environment.
Okay.
So that's there already.
Okay, thanks.
You're using for
No hypervisor.
Okay.
No hypervisor for containers.
So how the customer can set up OpenShift Enterprise on premises?
No. So basically, so if you know Go language, it's just a binary. So you can just take a binary, install it, and your OpenShift will be ready.
Okay, and then you can run containers on
Yes. With Kubernetes. So Kubernetes will take care of all those things. So basically you define your app that we're going to deploy, what definition you have. So what would happen is eventually you would have a JSON file or YAML file in which you define your application, your definition, your rules or whatever, and through that rules you can deploy it, and those rules will be followed when you run the app. Okay, one last question, then we'll talk offline.
What about monitoring?
Monitoring, so there is monitoring at different level. So you can do monitoring at the Kubernetes level through something called cAdvisor, and there is another name, another project. So you can do at the Kubernetes level, you can do through cAdvisor and all those things, and at the OpenShift level, you can, I think, do with something called as Cockpit. Cockpit is a GUI tool which what we have built so that you can use to monitor the resource for each containers, each pod, all those things. I think we'll take offline all the questions after this. I have some stickers which I'll leave at the counter there.